by, etc. So it was entertaining. There were other ones where we had. I remember there was one where we spent months solving this problem in Alaska. It was a new switch up in Alaska. It was using it was one of the first switches with signaling system 7 or SS7, where they have common channel for signaling. In the old days, all the signaling for the trunks was in the channel. So before, you kind of went off hook on the channel, just like a telephone, and you sent some pulses or some tones down the channel, and there was a tone receiver on the far end. And this idea of doing the signaling in a separate channel was new. And so we were working on this switch in Alaska, and it kept crashing. And it was crashing so badly that you couldn't even get into the switch on a terminal. On site, a physically connected terminal had no response. Like, it would take 20 seconds for each character that you typed to get reflected back to you. Mm-hmm. And so clearly something was going haywire inside the switch. It was eating all the CPU time. And so we had to rewrite the runtime scheduler and reload the switch with a new scheduler just to get terminal response. So once we got terminal response, then then we can get in there and start looking at the status of things. And it turns out that the problem was caused by this new common channel signaling software. And it what happens is, for redundancy, everything in telecom is redundant. So the switch has two CPUs that are running side by side the exact same code, and there's special hardware that monitors them to make sure that they're working identically. And if they get into a mismatch, then they get into a whole dispute resolution process to figure out which one is wrong. All the trunks have multiple channels, and each of the channels, they're routed in different ways. So here we have this common channel signaling. The hardware, they have a main signaling channel and a backup signaling channel, and they go out onto two different cards, and the two different cards are attached to two different sets of wires. And the idea is that if you lose one signaling channel, then you switch over to the other signaling channel. And so the thing was switching back and forth between these two channels, and it would get switched to the other one, and it would notice that it wasn't very good, so it would switch back to the first one, and notice it wasn't very good, it would switch back to the second one. So it was switching back and forth. So all this high priority work of recovering the signaling channel was eating all the CPU on the switch. So the on-site techs go out there and they kind of follow the wires. And so these two wires that the signaling channels are running on, they're two DS1s, go out of the switch. They go via very different routes, and they end up at the exact same satellite station. That sends a signal to a satellite, which then goes down to the US lower mainland. And okay, that's not a good thing. That means it's not really redundant. There's a single point of failure. But why is everything crashing? And it took them a while to figure out that occasionally a herd of migrating caribou would stand in front of the receiving dish, and the cloud of steam coming off their backs would disrupt the satellite signal.
That sounds like the original story about bugs, where the name bug comes from, because bugs were actually eating wires.
Yeah, so the moth was stuck on the coils of the old core memory. Yeah, it's a very similar kind of thing. And